In this video, we're going to look at additive color theory and how it relates to our optics unit. So the question is, how does light give objects color? So when light hits a black object, all the light gets absorbed, so no light returns back to your eyes. But we see different colors depending on the light that is reflected back to us. So if we were looking at something that was red, the other colors of light are being absorbed, and the one that's reflecting back at us is what we see. So the one that doesn't get absorbed would be the red, and that's what we see. So we'll do a little practice here. So the first question is draw arrows to show what colors of light would be reflected by each object. So if we're looking at a red apple, we would expect that the color that's coming back off would be red. So red is bouncing off. And then if we're talking about green, so this green pepper, it's absorbing all the light except for green. So green is bouncing back at us. So we'll just review clarity. We would have learned that last year in grade 9. So it shows the difference between transparent, opaque, and translucent. So clarity is how see-through something is. So transparent, the light from this candle is passing through this transparent material. So there's not much bending of light. The light passes through. Opaque, the light travels and hits the opaque surface and then just bounces back. It's not passing through at all. Whereas translucent, it goes through, but there's some distortion. Some of it might not go through. You can't actually see the item clearly through a translucent object. You might be able to see the outline, but not the actual details of the object. So transparent, light all goes through. We can see clearly. Opaque, no light goes through. You can't see through it at all. Translucent, you can kind of see through it. So what would you expect to see if white light was sent through a prism? The answer is the white light comes through, it gets dispersed through the prism, and it actually breaks the white light into the individual colors of the color spectrum. And then what would you expect to see if light of different colors, like red, green, and blue, are shone on a part of the floor? Would it shine, would the floor look red? If those colors overlap, would that make a difference? Those are some things we're going to learn in this video. So additive color theory. It says that if you add different colors of light together, you can reliably make different colors. So if we look here, we have the 3 primary colors of light. So we have red, blue, and green. So the RGB spectrum, red, blue, and green are the 3 primary colors of light. When you overlap red and blue, you get magenta. When you overlap red and green, you get yellow. And when you overlap blue and green, you get cyan. When all of the 3 are overlapped together, you'll get white light. So that's something that you can play with in our labs and see if that actually is true. So this is what I just talked about. So the primary colors of light are red, green, and blue, RGB. The secondary colors, which are made by combining primary colors, are yellow, magenta, and cyan. So yellow, magenta, and cyan. So complementary colors are any 2 colors that when you add them together will produce white light. So for an example, cyan, which is right here, is made when you add blue and green together. If I then added red to that, you'll get white light because cyan is a mix of blue and green, and we know that when we add red, blue, and green, we get white light. Same idea. So what are some of the other complementary colors? So if I mixed red and green together, I get yellow. So then if I mix that yellow and blue together, I would get white light, and so on. So some applications of additive color. Television is based on additive color theory. You actually have 3 LEDs that contribute to all the colors that you see on your television screen. So red, blue, and green. Theater light are the same thing. You mix and match the different color filters to get the lighting that you want on your stage. So you get an opportunity to try this out. So if you go to the interactive simulations and select the color vision, the activity, you can try some of this out, where you can actually try to see what happens when you mix and match colors. And here's some problems to try. So what combination of colors would you need to set a blue light or a mood light on an actor in a tranquil theater scene? What would you need to do to cast a yellow daytime light on your home? What would you need to do to make a white filter if you only had a cyan, or sorry, make a white light if you only had a cyan filter? How would you do that if you only had a green filter? How would you turn magenta into blue? How would you turn green into yellow or yellow into red? So take a look at those complementary colors and the additive color diagram and see what you need to do each of these.